How do we limit these huge industrial users? We can't supply enough water to cool a half gigawatt facility. We're not going to, we don't want to do that, we just don't have the capacity and the reserves.
Matt, it's a pleasure to be here with you today. Why don't we just start off a bit about your role and you as a professional coming to where you are at the moment in your career?
Yep, so I'm working with AECOM at the moment as their high-tech market director. That for me basically means that I'm working on data centres across Australia and APAC in particular. For me, it's still very much an infrastructure role, so I'm still working with a lot of co-location providers in particular and hyperscalers, building out the physical infrastructure and the data centres that are required to deal with the huge expansion that we're seeing at the moment.
So one of the things that I see driving the huge expansion is where my career path is the data side. And when I think about AI and the growing exponential nature of the amount of power that we're going to need, I'm seeing this push-pull that's going to happen with the need to be energy sustainable with the consumption of AI power. Where do you see that going in the future?
We're already seeing a lot of evidence that the AI growth is starting to drive a massive increase in power. So there's a lot of comparisons around at the moment, comparing a typical Google search to an AI search and the amount of power that it consumes. As AI becomes more and more prevalent in user cases and how we're actually using and consuming data, we're going to see a massive increase and spike in power consumption. GPUs every generation are getting more and more efficient and they're getting better, but the sheer scale and growth at the moment that all of the major cloud providers are going through means we're going to have a massive surge in data center capacity. We're starting to see it coming through on the co-location side in particular. If you look at the size and scale of the investments that they're making as co-location providers now, they've gone up from sort of 40 or 50 megawatts as a data center facility. We've blown past the 100 megawatts and we're talking about 500 megawatt campuses now. So everybody is buying these huge sites with the intent of building multiple different facilities on there. But that's coming at a huge cost though, in terms of power provision. And the other side of things as well, being obviously the sustainability side. A lot of data centers are still using water cooling. It's the cheapest option for them. Helps keep the cost per megawatt down for delivery and for customers and that flow on. As we're starting to get to these bigger figures, we're becoming true huge industrial users of power and water. And what's actually happening is we're seeing some pushback now from a lot of the authorities. They're not keen to provide us with half a gigawatts worth of water to cool our systems down. So it's starting to drive the conversation of pushing us down towards, for instance, an air-cooled route for all of our facilities. But that comes again with an impact on power. So what we see is that some of the costs that you're going to start to see coming through from these new facilities are going to by de facto going to be higher because the power consumption is going to be higher. Air-cooled chillers, for instance, which are going to be an absolute fundamental now for putting in AI racks. You look at the next generation of racks coming, next generation of processors coming through for NVIDIA, they're all direct water cooled. So we see a difference there in the fact already that we're having to move away from some of the air-cooled environments that we've been pushing towards for the last 10 years. Moving into a different approach where we're going back towards the water cooling again. And that means air-cooled chillers, and again, that impact on power because we can't get the potable water anymore from the suppliers because they're prioritizing that for people, which is probably the thing that they should be doing.
That's interesting because, GPUs typically run pretty hot, so there's going to be increasing need to cool them. And when we're talking about air-cooled versus water-cooled, I remember it would have been maybe 15, 20 years ago in construction engineering, running chilled water through beams seemed to be the popular thing to do because it would keep the building at a stable temperature. But you're saying that there's this interesting push-pull between the air-cooled and the water-cooled. Is that primarily driven by the industry? Is it driven by government? Where's it coming from?
It's being driven a little bit by government. It's being driven by the authorities, basically. So if you look at here in Sydney, we have Sydney Water. They're the primary body responsible for delivering potable water, dealing with sewage, dealing with all of the takeaways. And they're starting to find that we're hitting constraint capacities. If you looked at an example, for instance, in New Zealand a couple of years ago, they're very reliant on hydropower, which is great, very green, very renewable energy source. They had a drought through the summer and they were down to about 20% of their reservoir reserves, which means that the power that was available to them was starting to become limited and they were starting to get concerned about supply. Now, if you have a large multi-megawatt facility for a data center, sucking in all of that water, it's coming out of the authorities' water buckets that are available, which should be there to serve people. And it's not. So what they're just starting to do is they're starting to look at how do we limit these huge industrial users. We can't supply enough water to cool a half gigawatt facility. We're not going to. We don't want to do that. We just don't have the capacity and the reserves. You need to find an alternate. So they're starting to get pushback from those authorities that have got alternate and higher callings in terms of serving people rather than serving industrial equipment.
Well, one of the things that I saw that was interesting in New Zealand as well is Mercury New Zealand built out a digital river. So they used IoT devices to model how hydroelectricity happens, built out a digital version of the river so that they could predict what was the most effective way to capture energy. Do you see digital twins or any sort of expansive digital technology playing a crucial role in data centers?
Not so much in the data centers themselves, but I think that sort of massive GIS and massive levels of sort of countrywide sort of topology and engineering, building up those digital twins. I think we're starting to see more and more of them. So councils in particular, if you look on there at the moment, you've got a lot of things on there, digital twins on there for flood modelling maps. You've got a lot of information on the infrastructure side of things for it. So those digital twins are helping to enable the growth and development of a lot of sites and a lot of infrastructure. And I think we're sort of seeing that coming across with those big authorities again as well. So, but for data centres, obviously, that's just a massive workload. Having to build, maintain and operate a digital twin and then make it available for public information. It's a huge amount of data to be using and updating.
It would be. So with all these issues around cooling, the increasing costs, the megawatts, I guess one of the big follow-on is how this impacts the customer at the end of the day, especially because what we're hearing from a lot of the speakers at the moment and experts is if you're going to move workloads purely on a cost basis, it's a bit of a pipe dream. So moving to public cloud is about considering what's open, modular and agile. Moving to a data center might be how you calculate your edge so that you're capturing better data from your IoT devices. How is this going to impact the customer and what are the cost implications at the moment?
On the data center side of things, if you look at co-location, there's been a real driver to try and bring costs down to make us more competitive. The less money we have to spend on data centers, the less money we have to spend on power, so bringing your PUE down, for instance, the less money we have to spend on that, the cheaper we can make the product available to the end user and to the client. I think it's an inevitable outcome, though, that with things like moving to air-cooled facilities rather than water-cooled facilities, the cost per megawatt of capacity is going to go up. So I think if you look at it from a perspective of paying for that service, I think you can expect to see some of that cost flowing through to the end users as the cost of actually building and maintaining these facilities increases. I think that's an inevitable outcome, and I think it's probably something as an industry we're actually going to have to get used to as well, because some of the more dramatic changes that we're looking at in terms of sustainability are going to drive some fairly substantial changes in the costs as well associated. We've gotten used to, certainly with like a lot of the cloud providers, paying for a fairly cheap product. They've done a great job in bringing down the power consumption of their facilities to get as much as they can out of each different facility. But as we start to implement some of these more sustainable outcomes, putting in things particularly for your scope 2 emissions and scope 1 emissions around there, of putting in low carbon concrete into the buildings, shifting again, like I said to you, using an air-cooled chiller, you're going to find that these are more expensive alternatives. And they're going to start to impact that overall cost per megawatt of what we can do, and that's going to flow onto the customers as well.
Well, what ended up happening with liquid immersion technology? It seemed to be something that people were discussing a bit. Is that still around, or has it died out?
It's still around, and everybody got excited about it probably 12 months ago, because we looked at it and thought this is going to be something we're going to have to do. With the densities, we're pushing up to 100, 120 kilowatts in an individual rack now with the AI loads and these high capacity racks, and it makes sense that we move to an immersion cooling solution. But I think what's happened particularly with NVIDIA being the market dominant player on GPUs, as they've announced their next generation of chips, they've come out with a direct connection for water cooling. So why go for a full immersion connection on there when the chip manufacturers themselves are now starting to work and looking at how they build up a rack, put in a a cooling distribution unit associated with it and just doing the cooling that way. So it does one of two things. It means that we don't have to go for necessarily have to go for a really sort of high density solution like an immersion cooling. And it also means that all of the facilities that we've got built at the moment can be turned into a kind of a hybrid environment. So we've got to go through a fairly extensive transition period where we're moving from the types of data centers that we've been building for the last 3, 4, 5 years. And if you look at a data center, typical build time for it, even with accelerated practices, is usually at least 3 years. Probably closer to 5 once you factor in all of the land purchase, moving through all the council applications, getting to the building, design, going through into construction. It's a 3 to 5 year period. So we don't pivot quickly as an industry. We can't. It's a large, heavy scale industrial application and industrial development. So as we're starting to see some of these things happening through with the AI racks, these changes are moving faster than we're able to move as an industry in building and construction. So we're going to end up with probably for the next maybe 10 years, a fleet of data centers which are not going to be purpose-built for high-density cooling loads, not going to be purpose-built for AI. We're going to end up with a hybrid environment. So we're going to have to find ways to make that work in existing building footprints to be able to deal with those high-level loads. And that's going to be the challenge, I think, for the next probably maybe 5 years.
It's interesting. So there's going to need to be that hybrid way to manage the growing need of AI. And with the data centers, what's the role in enabling customers to benchmark their own emissions? So the data center is always trying to be greener, more net zero, but obviously each customer is going to have their own infrastructure requirements within the data center, and they want to be able to do upstream and downstream. What's the duty of data centers to provide their customers with accurate benchmarking?
I think it's critical. It forms a major part of the supply chain for your data. So it's very easy, and we tend to overlook it in this industry, that the vast majority of people don't understand where the cloud comes from and the impact the cloud has. And you see that all the time when you have conversations with people on the street. They don't even think about it being somebody else's computer. And when we start to look at benchmarking and monitoring and seeing what the carbon footprint is for our use of data, understanding how much is being used in that full carbon chain with the data center facility is critical. Now, it'll change a little bit depending whether you're a hyperscaler who's operating your own facility and you've got a lot more control over how you're doing that, or whether you're bringing your data needs to a co-location facility. If you're bringing it to a colo and you're a fairly sort of small user of a space within there, then understanding your carbon footprint in there is going to be very much reliant on the co-location provider being able to give you that accurate information. So for those colo providers in particular, being able to go through and understand the benchmarks for both building the facility in the first place, all of the embedded energy that goes into it in terms of the concrete materials, power, then going through even into just sort of straight power usage, and then into the scope 3 emissions of the ongoing operation and being able to run it and bring people in to do that. Getting that accurate information and understanding how you can apportion that to a particular level of workload is going to be critical, and I think it's probably going to end up as a power percentage. So they'll look at it and you'll build it up and then work through it as a percentage of power of the facility's capability, and just apportion a level of carbon from the build of that aggregated over time. But it's going to be an interesting one, and I think it's going to be harder for those sort of smaller to mid-sized players who are going into colos and running their own facilities. And running their own things and doing sort of can't say an on-prem solution, but it's an enterprise solution within a colo. As opposed to a cloud service where you literally buy your cloud service and then either Amazon or Microsoft or Google will just give you a figure, and they're able to give you just a figure based on the amount of compute capacity you have. So it's going to be a challenge, I think, for those operators in that sort of space where there's some physical racks that are owned by you.
Cool. Look, I always like to finish this off with, how does your role look different in 10 years' time? How do you see it as evolving?
I think for me, we're always going to have a need for physical data centers. I think something that's going to really happen over the next few years, though, is hopefully we'll go past this massive peak growth that we've been going through at the moment, particularly with AI. And what we're going to end up with is a huge fleet of data centers that are in operation, They're going to be coming up to 8, 10, 12 years old. Some of them coming up to 15 years old. I think one of the big things we're going to have to do is start to look at how do we repurpose those data centers? How do we evolve them? How do we change them? How do we grow them to be suitable for new use? So I think this massive surge we've got at the moment of building new facilities is going to dampen down. And I think we'll move to adaptive reuse of the existing facilities and working out how we can get more out of them in the future, how we can change them, upscale them, and modify them. So I think that will be probably, for me, the biggest change. Other than that, again, we'll probably see a change in technology again. Who knows what we're going to be on in terms of
quantum or whatever
rack technology, quantum technology. What's going to be the cooling requirements? Are we going to be pushing up the temperatures again? And we do move slowly as an industry. We're quite conservative. But I think some of these things, particularly with technology changes around the compute types, is forcing us to move at a fairly fast pace. So we'll see some of that start to come through.
We'll see. Quantum will be interesting because the cooling requirements behind that are epic, close to Kelvin.
Yeah.
Yeah.
Very, very different. Very, very different requirement.
Yeah.
As we're moving at the moment into an industrial space, again, it's just going to take it beyond that and further into that sort of high level industrial capacity.